Welcome to Intermolecular Forces, Solids and Liquids, Ways of Expressing Concentration in a Solution. My name is Dr. English, and today we're going to be talking about dilute versus concentrated solutions, mass percentage, parts per million, mole fraction, and molarity. So let's talk about ways of expressing concentration. Remember, a solution is a homogeneous mixture that contains one or more solutes dissolved in a solvent. So in a given solution, concentrated solution has more dissolved solute than a dilute solution. So if we have two beakers here, each with the same amount of water in it, adding a little bit of salt would be considered a dilute solution of salt, and adding a lot of salt would be considered a concentrated solution of salt because there's more solute in the solvent. The most commonly used expressions for concentration are mass percentage, parts per million, mole fraction, and molarity. Let's look at our first one of mass percentage. The formula for mass percentage is the mass percentage of the component equals the mass of the component in the solution over the total mass of solution times 100. So let's look at an example. An aqueous potassium nitrate solution is made using 72.5 grams of KNO3 diluted to a total volume of 2 liters. Calculate the mass percentage of the solution. Assume a density of 1.05 grams per 1 milliliter for the solution. We're going to start by taking our total volume, which is 2.00 liters. And what we need to do is convert that into a mass. So we know that for every 1 liter, there is 1,000 milliliters. And then we're going to use that density that they gave us, which tells us that for every 1 milliliter, there is 1.05 grams, which we see right here. Now, I know that I've set this up correctly if all my units cancel, so liters cancel liters, milliliters cancel milliliters, and I'm left with grams, which is the unit that I want in the end. So if I work this out, I get 2,100 grams of solution. Now what I'm going to do is I'm going to say, well, that percentage is going to equal the part over the whole. And the part is the 72.5 grams of KNO3. The whole is equal to this mass that we just calculated. So that is going to be 2,100 grams of solution. And then I'm going to multiply the whole thing by 100. And if I work this out, my answer should be 3.45%, which is my mass percentage of KNO3 in solution. Now let's talk about parts per million, or ppm. This is expressed as 1 milligram of solute per 1 kilogram of solution. The formula that we use here is parts per million of component is equal to the mass of the component in the solution over the total mass of solution times 10 to the 6th. Let's look at an example. A 3-gram sample of groundwater contains 3.5 parts per million of arsenic ions. How many grams of arsenic are in this sample? So they give us the parts per million of the component, which is 3.5 parts per million. And that's going to equal the mass of the component in the solution, which we're going to solve for, over the total mass of the solution, which they tell us is 3.0 grams, times 10 to the 6th, which is really just a million. Now to solve for x, what we're going to do here is take 3.5 parts per million. We're going to multiply that times 3.0 grams, and that'll be equal to x times a million. And then if we solve for x, we'll find that to be 1.05 times 10 to the negative 5 grams of arsenic ions, or if we were to do this to the correct number of significant figures, 1.1 times 10 to the negative 5 grams of arsenic. And that is how you solve for the mass component in solution, in this case our X right here. Now let's talk about mole fractions. The formula for mole fraction is the mole fraction of the component is equal to the moles of the component over the total moles of all components. Note, mole fraction has no units, and mole fraction ranges from 0 to 1. A solution of salt with a molar mass of 90 grams per mole in water has a density of 1.29 grams per milliliter. The concentration of the salt is 35% by mass. Calculate the mole fraction of the salt in solution. Now, the first thing that we should notice here is that we really don't need to use the density because we're not involving volume. So we can basically ignore this part right here because what we are trying to do here is to find the moles of our component over the total moles. The key thing here is to look at this 35% by mass. So what we're going to do is we're going to assume a 100 gram sample. So our solution here is going to equal 100 grams. Now we know that the concentration of the salt is 35% by mass. So my solute is going to equal 35 grams. And if I subtract these two, my solvent is going to equal 65 grams. And they tell me that the solvent is water. So the next thing that I'm going to do is I'm going to convert each of these to moles. So 35 grams of my salt. They tell me that for every 1 mole of this particular salt, that's going to be 90 grams. And then I have 65 grams of water times 1 mole. And I know that the gram formula mass of water is 18 grams per 1 mole. So 35 times 1 divided by 90 is going to be 0.3889 moles of salt. And 65 times 1 divided by 18 is going to be 3.611 moles of water. So what I need to do here now is to take the moles of salt and divide it by the total moles of the salt and the water. So my moles of salt was 0.3889 moles here. And my total moles, if I add up my 0.3889 and my 3.611, that's going to be a total of 3.999 moles. And if I divide those two, my mole fraction is 0.0972. And that is how you find the mole fraction of the salt in solution. Finally, molarity, and this is really a review. We've already worked with molarity this year, but let us remind ourselves of the formula for molarity. So molarity is equal to moles of solute over liters of solution. Remember, molarity will change with a change in temperature. So as the solution volume increases or decreases, our molarity will increase or decrease. So you need to pay attention to that. Let's look at an example. 15 grams of toluene, C6H5CH3, dissolves in 180 grams of benzene, C6H6, to form 221 milliliters of solution. Find the concentration of the solute. Now, I know some of you might be saying, wait a second, that doesn't work out. How did you get 15 plus 180 and get 221 milliliters of solution? Let's just put it out there that maybe there was a density issue going on here that's not really related in the problem. But you know what? Let's just roll with it. So the 15 grams of toluene is going to be our solute, and the benzene is going to be our solvent, and they do give us a total volume of solution. So the first thing that we need to do is take our 15 grams of toluene, which is C6H5CH3, and convert that into moles. So 1 mole of C6H5CH3 over, I'm going to tell you that the gram formula mass of toluene is 92 grams of C6H5CH3. And if we work this out, we get 0.163 moles of toluene. Now we need to recognize that our 221 milliliters of solution really needs to be in liters. So if we convert that over, we're going to have 0.221 liters. So now we're going to say molarity is equal to moles over liters. Our moles is 0.163 moles of toluene. Our volume in liters is going to be 0.221 liters. And if we divide 0.163 divided by 0.221, we find that our final molarity here is 0.738 molar. And that is an example of how to do a molarity problem. So what did you learn? We went over the difference between a dilute versus a concentrated solution. We did an example of mass percentage, parts per million, mole fraction, and molarity. Need more help? Feel free to contact me. Have a great day.